Okay, so the book does not believe quite as strongly in you should be able to parameterize surfaces as I do. So they just give you a dArea for graphs, they give you a dArea for spherical, and they give you a dArea for cylindrical. So you just you could memorize these formulas, or you could just remember that you take the partials and cross them and then figure out your orientation. Right? So I'm going to show you where they get the graph one, just quick. So if you're parameterizing a graph of, say, f of x and y, right? What was your parameterization for that? Yeah, x, comma, y, comma, f of x and y, right? That's literally what it means to be a point on the graph. Okay? So now, if I want this thing, okay, here's my surface, right? Here I am. Oops. I don't know why he has a stick for a head. Got his head stuck in a vice. Okay. Which way is which? If you want this to point up, you want
X, then Y, X.
and so Rx and Ry, right? So if you want this to point up, you should take the x derivative and cross with the y derivative, right? Okay, so let's get those quick. So Rx and Ry. So what's Rx?
1, 0, then Fx of xy. Okay?
You guys good with that? Okay, what's Ry?
0, 1, partial of f given partial of y.
Okay, so then when you cross this should be relatively easy, right? So you go, okay, there's an I, a j, and a k, and I'm taking a determinant. Right, so I'm going to get my dArea thing, right, is going to be,
Let's see, I of negative partial f partial.
so I get 0 minus partial fx.
Then you get minus partial fy.
I get partial fy, and I need to make it negative, so yep, I got minus partial of f with respect to y.
And 1.
And 1. And then, what do I need? dArea needs d what? So this is the vector you're dotting
dx,
with,
dy.
and then you need a dx, dy, or a dy dx, right? So you could literally just memorize this thing, right? And it's up to you whether memorizing this is easier than remembering how to get it, or vice versa. Personally, I find that I'm more prone to make little mistakes in the order or signage or something on this than I am to make a mistake in cross-producting and remembering, but what else? Either way. You guys cool? Please note, this one's a lot easier than spherical, right? So you just take these partials and do it.
Is this in any way related to what we did when we just looked at a graph and pulled off a normal vector visually a while ago, like on the first test or something like that? It was just give me...
Yeah, so on the first test, we were pulling normal vectors off of planes, right? This is what you'll get if you have ax plus by plus z equals 0, right? Fine. You have an actual plane in an arbitrary way, right? Okay. If you solve for z and treat it as a graph, you'll get the same thing as if you parameterized and fiddled with it, right? So yes. Cool. Questions, thing? Okay. It's this solve for z step that's a little different, right? There I'm getting if I just pull off the normal vector, which is ABC, right? It's a vector parallel to this one, right? But the parameterization gives you that you can use dx and dy, and on that thing I'd have to use slightly different. These guys wouldn't be quite the same. Cool.